So I think I might have lied to you. We're actually going to do two problems in this part. I know you're heartbroken, but while you're sobbing, we'll continue to work on this factoring. We're essentially listing the zeros here. And while in the last one we used synthetic division was the only way to do that one. You couldn't factor such a large polynomial. The key to this one is, well, it's only 3 terms, and when you see through terms in math, you've hopefully been conditioned that to check, is that factorable? And this one here actually is. So right here, if we're going to find all the zeros, we could factor this. The difference being, instead of writing just x and x, this isn't enough because x times x is only x squared. I want to multiply to x to the 4th. To do that, I'm going to write x squared and x squared. All right, so I ask myself, what multiplies to negative 20 and adds to negative 1? I hope that's negative 5 and positive 4. Okay, so now that I've factored, I should be able to list all my possible zeros, set up 2 equations. X squared minus 5 equals 0. X squared plus 4 equals 0. Well, add 5 and add 5. X squared equals 5. Be careful, the trap people try to do when they square root both sides. People try to tell me square root of 5 is the answer, but that's not the case. It is plus or minus the square root of 5. The same reasoning goes here. When you take the square root of negative 4, square root both sides, you get x equals plus or minus 2i. All right, so that was a quick one, listing the zeros. Radical 5, negative radical 5, 2i, and negative 2i. Still the same directions as the last problem, with a totally different method. Here it was factorable. If you go back to the last one, this problem just is not even close to factorable. There's not even a grouping possibility. Okay, last one for the day. This one's going to be a tricky one. Okay, summing up everything we've done. All right, find all the zeros of f of x given that 1 plus 3i is a 0. Good. If 1 plus 3i is a 0, what else must be a 0? What did we learn today? Hopefully we learned that 1 minus 3i must also be a 0. Given that, now I don't even want to worry about this f of x right now. I'm going to come back to that whole function later. What I am worried about is right here, if 1 plus 3i is a 0, what's the factor that makes 1 plus 3i a solution? So x minus parentheses 1 plus 3i, this right here in the red parentheses is the factor that makes this a 0. That's tricky. Also in this red set of parentheses, 1, I'll use green here, 1 minus parentheses 1 minus 3i, sorry, this should have been an x minus parentheses 1 minus 3i. Again, this second red set of parentheses is the factor that makes 1 plus 3i a 0. That's tricky to set up. All right, but I am going to work. I know both of these red set of parentheses are factors. All right, because they're factors, I can multiply them. They're both factors. I can multiply them. Multiplying them as is tricky. I'm going to show you a little shortcut. If I just distribute the minus sign, x minus 1 minus 3i, x minus 1 plus 3i. Now, what I notice, and again, this gets tricky, but it's a shortcut. The green sets of parentheses are exactly the same. They both contain x minus 1, and the one is a minus 3i, the other is a plus 3i. Essentially, you do have a difference of 2 squares here. You can multiply probably in the form, now, if you wanted to multiply a trinomial by a trinomial, you could. You'd get the same answer I'm about to get. What I'm going to do is do it in a slightly easier way. And what I mean by that is I'm going to take x minus 1 and multiply by x minus 1 and just call that x minus 1 squared. And because it's a difference of squares, I don't have to worry about these 2 blue lines. That's the outside of FOIL. That's the inside of FOIL. I don't have to worry about them. I know they're going to cancel each other out. If you don't believe me, you can go ahead and give it a shot. And then the last part to this is that's going to be minus 9i squared. But again, we don't write minus 9i squared. Instead, we're going to write plus 9. So I squared is equal to negative 1. Okay, so now I got to simplify this. That's not too bad. X squared, I FOIL. I get minus 2x plus 1 plus 9. So I can clean this up. When I multiplied this big set of red parentheses, I got as an answer x squared minus 2x plus 10. This was a factor of this. So that because they're still equal, this x squared minus 2x plus 10 is still a factor of this function. If it's a factor, it should divide in evenly. Well, I can't use synthetic division here. Synthetic division only works for when it's x plus something or x minus something. Here I'm going to have to go back to our standard long division that we talked about at the beginning a couple sections back. So because x squared minus 2x plus 10 is a factor, it should divide evenly into f of x. Let's try it out and see if we are correct. Alright, so regular old long division here. I say to myself, what times x squared is going to be x to the fourth? Well, that's x squared. X squared times x squared is x to the fourth.
Charles Mitchell, your transportation is here. Charles Mitchell, your transportation is here. Thank you.
Multiply, keep going. I get negative 2. This is going to be negative 10. Ooh, let's go back there. Go. Let's see if I can erase that. It's going to be not right now. Hold on. Something's being strange. I don't know what's going on. All right, let's try this again. X to the fourth, we are going to get minus 2x to the third, and then we're going to get plus 10x squared. The key thing that I've done is make sure you realize how I've lined up these exponents. Right? That's a pretty important part. When you are doing long division, you are subtracting this entire set of parentheses. I like to think of that as adding the opposite of every one of these terms. So this cancels. This is negative 1x cubed. That's going to be negative 4x squared. And I'm going to bring down the 2x. And I go back and ask myself the same long division question I asked before. What times x squared is going to be negative x to the third? And it's going to be negative x, which I already wrote down. So that's going to be negative 1x cubed plus 2x squared minus 10x. Right? Go back to green. I am subtracting this whole set of green parentheses. When I think of subtraction, I think add the opposite of every term. So these will always cancel out. This should be negative 6x squared plus 12x. And I bring down the minus 60. Hopefully we get a whole number answer. We go back to the very beginning. We say what times x squared is negative 6x squared. So it's going to be negative 6. We do another multiplication. Negative 6x squared plus 12x minus 60. And our last time we're going to do a subtraction. When we think subtraction, we think add the opposite. Change every single sign. Cancels, cancels, and cancels. The remainder is 0. So we have proven that x squared minus 2x plus 10 divides evenly into f of x, and it leaves a remainder of x squared minus x, and it goes into evenly x squared minus x minus 6 times. So what we can now say is x squared minus 2x plus 10 x squared minus x minus 6. Those are your factors. We could continue to factor this portion right here. We could continue to factor it. The only other piece that's still factorable, that factors down to x minus 3, x plus 2. So our final answer those are all of our factors, and let's just check the directions. They asked us find all the zeros. So they already told us these two were zeros. We had those already. The last two zeros would be 3 and negative 2, along with the 1 plus 3i and the 1 minus 3i. 1 plus 3i and 1 minus 3i. Those are all your zeros. It's a tough problem.